Good morning.
Good morning.
I'm going to start the class for today. I will share my slides for chapter 3. I'm going to go right where I left off last time and go through the material. Let me share my slides. All right, can you see my chapter 3 slide page?
Yes, sir.
All right. We were talking about chemical bonds. We talked about chemical bonds. Basically, two types of chemical bonds, ionic and covalent bonds. We introduce you to ionic bond formation. We also talked about naming cations, simple cations and simple anions. So we're going to continue from there, 3.5. And then we're going to go on to covalent bonding and rest of the topic in the chapter 3. Let me go there. I covered up to 27 last class period. So I'm going to start from polyatomic ions. Ions could be complex. Most of the ions we talked about are simple monoatomic, one metal, one non-metal. We talked about their names, mainly main group elements. There are few polyatomic ions. Polyatomic means more than one atom, two or more atoms with a charge. Mainly polyatomic ions are anions, except one, ammonium ion. This is the only cation we call polyatomic ion, positively charged. It's called ammonium ion. There are all others are anions. First one is hydroxide ion, OH minus. Second one is nitrite, NO2 minus. Third one is nitrate. And the fourth anion is acetate. Sometimes we write two forms of acetate. This one is two oxygens are spread out. Here, two oxygens. This one has only one, they're condensed. Perchlorate, cyanide, permanganate, one negative charge. Chromate, two negative charge. Dichromate, CrO2O7. Cr2O7 2 minus. You have to remember charges and the formula of polyatomic ion to name these compounds. There are a few other polyatomic ions that are coming from acids. Carbonic acid is H2CO3, carbonic acid. When carbonic acid loses a proton, hydrogen plus, it forms bicarbonate ion. That's a common name. Or its systematic name. Systematic is normally following a rule, hydrogen, carbonate. There's hydrogen here, carbonate. Carbonate ion is CO3, 2 minus. That's coming from carbonic acid. From sulfurous acid, which is H2SO3, that's sulfurous acid. Sulfide ion is formed. When it loses 2 hydrogens, it becomes 2 negative. That ion is called sulfide ion. Hydrogen sulfide ion or bisulfide, common name, just like this one. These are common names. Sulfate is from sulfuric acid. Sulfuric acid is similarly, you can have hydrogen sulfate or bisulfate and phosphoric acid, H3PO4, also PO4, forms losing 3 hydrogens. 3 hydrogens here produce phosphate. Phosphoric acid can lose up to 3 hydrogen plus protons. First one is when you lose 1, it's a dihydrogen phosphate. When you lose 2, it is called hydrogen phosphate. When you lose all 3, it's called phosphate. So please try to look at these formulas and remember charges and the names. What is the charge on ion formed by group 7A? I think we talked about that, -1. 7A is a non-metal halogen group. Therefore, it gains 1 electron to form the octet. Answer is C. What is the charge on the ion? Iron atom. This iron atom. There are 2 iron atoms. Iron is a transition element. Therefore, it can have more than 1 charge. Therefore, we are not sure which one. Oxygen is always 2 minus. Therefore, total charge on 3 oxygen is -6. In an ionic compound, the cation and anion balances off and become neutral. Therefore, total on 2 ion atoms is 6. Therefore, half of that, each ion atom has, each ion is 3. Therefore, ion atom is +3. So if you look at this, that's the answer. We need to figure out ionic charges from the formula. That's one of the questions. Which of the following ionic compounds are cations with positive 1 charge? This is 1A. Potassium is 1A. Normally, you look at the first atom in the formula. That's a cation. This one, we don't know. That's probably 3A. This is 2A. Calcium is in second alkaline earth metal, magnesium. And therefore, positive charge only formed by 1A. Thallium, in case this is +3. Magnesium is 2+. Calcium is 2+. That's the group number. So answer to that 41 is A. How do you name an ionic compound? Binary, 2 elements. What you say is magnesium. This is magnesium, charge is group 2A. Therefore 2+. Oxide is 2-. You check the charge balance on magnesium and oxygen after you figure out the charges, their balance. Therefore, you write down magnesium oxide is the formula. It's called magnesium oxide. You don't use prefixes or anything naming ionic compound. Therefore, answer is magnesium oxide. These are not correct. You don't use magnesium monoxide. Monoxide, you don't, no prefixes. Magnesium oxygen is wrong. The second element, magnesium oxide is oxide, not oxygen. Therefore, answer is C. What is the correct name for barium iodide? Can you tell me what it is?
Barium iodide?
That's correct.
Mm.
That's wrong. No iodine. Barium iodide, that's correct. Mono is not used. Barium diiodide, that's wrong. Therefore, only correct answer is B. What is the formula of a compound formed by barium and oxygen? Barium is 2+, oxygen is 2-. How do I know that? That's 2A, that's 6A. Non-metal gains 2 electrons. Metal loses 2 electrons. Therefore, charge is balanced here. You don't have to put more subscript to balance it. If it is not +2 here, you have to cross multiply. I am going to show a problem later. So this is that one. Because barium has 2 plus, oxide has 2 minus, you don't have to do anything, it's charge balance. These are all, this is kind of overdoing it. They are charge balance, but only the ion ratio is shown, 1 to 1. Simple ratio is shown. 1 to 2, that's not simple. These are now 2 to 1, that's not correct. That's 1 to 2, that's not correct. 1 to 1 is the correct. D is the correct answer. What is the correct name for potassium chloride? I said the name, potassium chloride. This is wrong. This is correct, both potassium. Monochloride is not right, monopotassium. You don't say mono. It's the same one of potassium. And normally ionic compound we don't use. C is the correct. Correct formula for aluminum oxide.
D.
What is the answer?
And Al2O3. D.
Yeah, that's the correct answer. How do I get that? Aluminum is in the 3A. Therefore, 3 plus cation is formed. Oxide is a 2 minus, 2A, 6A, 6A group. Anion with 6 electrons will gain 2 more electrons to make the octet. That's how you got aluminum 3 plus, oxide 2 minus. When you have a charge imbalance, the total charge on one aluminum is 3 plus, this one is 2 minus. If you write down this, that's not charge balance. This is 3 plus, this is 2 minus. This is 3 plus, 4 negative. There are 2 oxygen. This is 6 plus, 2 negative. When you look at this one, that's 3 times 2 is plus 6. Oxygen, that's the aluminum. Oxygen is 2 times negative 2. 3 times negative 2 is negative. Therefore, this is the answer, charge balance. D is the correct answer. What is the correct name of barium? Barium is, Ba is barium. What is hydrogen? It's a negatively charged anion, is a hydride. Hydride is negative. Therefore, answer is barium hydride. Dihydride, we don't use prefixes. Mono, that's not correct either. Barium hydrogen is wrong. This is ionic compound. Hydrogen is, here is negatively charged, 2 of them. So this is balance of 2 plus, 2 hydrogen hydride dash, 2 negative. Therefore, barium hydride is the correct. What is the correct formula of sodium fluoride? Sodium is +1. This is +1. Fluoride is -1. Oh, I'm sorry, -1. Therefore, it is balanced. You don't cross multiply like this one. Aluminum oxide, to charge balance, you cross multiply. Therefore, NaF. This is the correct answer. Others are not correct. Calcium and fluorine. What is the formula of this compound? Calcium is 2 plus. Fluorine is 1 minus. They are not charge balance. How do you balance it? You need to have 2 fluorides. Calcium 2 plus, 2 fluoride. Therefore, calcium fluoride formula is that. You don't write the prefixes, just the calcium fluoride, but the formula is CaF2. This is the correct one. Therefore, answer is B. Formula of polyatomic ions. Polyatomic ions are mostly anions, except ammonium ion. We talked about it. They have, polyatomic have 8, like phosphate, ite, nitrite, sulfide. If the name of a ion, polyatomic ion, end up in, it's most likely to be. Cations don't have 8. Polyatomic cation, monoatomic cation don't have. Monoatomic ion, like if it is only one atom, like chloride, bromide. So C is the correct answer. For the polyatomic ion that contains element nitrogen and hydrogen, choose the appropriate polyatomic ion from the responses. This is nitrogen, this is OH, -1. That is the one, nitrogen and NH4, that's the same. Nitrate is sulfite is. So therefore, B is the correct answer. Polyatomic ion that contains 3 oxygen atoms. Choose the appropriate polyatomic ion from the responses. 3 oxygen atoms. Nitrite is not 3. Ammonium ion is, hydroxide ion is OH -1. Sulfate ion is nitrate is NO3. I wrote nitrite. Therefore, answer is nitrate. Nitrates have 3 oxygen atoms. Answer is C. For the polyatomic ion, that has 2 negative charge. Choose the 2 negative charge. OH is same thing, here nitrate. The sulfate ion is the one you have 2 negative. Therefore, answer is D. Name formula of polyatomic ion. Name HCO3 is hydrogen carbonate. That's a systematic name. We talked about bicarbonate is a common name. Bicarbonate. This is called bicarbonate ion, common name. The I ending is usually associated with monoatomic anions like hydride. Hydride is 1 hydrogen. Which of the following polyatomic ion has the end with I? That acetate, 8, acetate. Hydrogen phosphate, hydroxide. That's I. That's 8. That's 8 also. Hydrogen phosphate, acetate, hydroxide. Therefore, answer is C. The formula of sulfate, you have to know this to check out. Sulfate is SO42 minus. Nitrate is NO3 minus. Phosphate is so these are the lists that you have to check. Sulfate is here. Nitrate is here. Same idea. Rest of is that's not correct. Sulfate. This is not correct. 3 minus. This is not correct. Neither is this. Therefore, only correct answer is D. You have to know the formula of polyatomic ion. Now, we're going to change the topic a little bit. In the periodic table, the main groups, which are tall groups within the S and P block, if you write down the periodic table, they are lanthanide and actinide. This is transition metals. This is lanthanide and actinide. These are main groups with 1A, A, 1A, 2A, 3A, up to 7A. They have fixed charges. Most of them have fixed charges. Transition metal have variable charges. That means more than one. So naming is kind of complicated because I'm going to show you how you name transition metals and lanthanide and actinide. Naming cations, which like transition metal, inner transition, lanthanide and actinide, they form more than one type of cation. So what you do is, after the name of the element, for example, iron 3 plus, and there are possibility of 2, you write a parenthesis. 3 for that, and just Roman numeral 2 for that, to show the charge on the transition metal or the element with more than, it can form more than 2 cations. Sometimes we use common system. S is the lowest, this is ferrous, lower charge, Ic is the higher charge. Smaller positive charge is As, Ic. This is called ferric. This is called ferrous. There's a table of these ideas. These are the most common ones in the transition metals. And there are a few elements like tin, which belong to main group 4A, also forms 2 plus and 4 plus. So in their name, you put the charge number in Roman numeral. This is Roman numeral 1, that's a 2, that's a 4 charge. For example, sodium, we never use parenthesis and number because sodium got only one charge, positive one. Therefore, it's not necessary to show the charge on the name of the cation. Copper is copper 1 plus, 2 plus. That's a highly charged ion, is called Ic ion, cupric ion, cuprous ion. Ion is, this is the lower charge here, is a highly charged +3 Ic ion. Mercury ion, mercury 2 plus ion is Ic, mercury 1 plus ion is mercurous. The copper comes from cuprium, Latin name, where you got the atomic symbol. Ferrum comes from, Fe comes from Latin name of iron. Mercury comes from Latin name, hydratherium. Stannous is 14, Latin name for tin. Do you get the idea? When you have transition metal or elements that can have more than one charge, You have to, in the name of the compound, you have to show charge on the cation in parentheses after the name of the cation. The name binary compounds of metals that form two or more different cations. Systematic name use parentheses. We talked about this. Roman numerals enclosed in parentheses. Common way of using ik and us. Ik is highly charged cation. Us means lower charge cation. Copper 2 plus is cupric. Copper, the charge on each copper atom is 1 plus cuprous. You use the parentheses or the common name cuprous. Iron oxide, that's the 2 plus here. Therefore, this is 2 plus. How do I know? Oxide is negative 2. Therefore, iron has to be positive 2. So that's oxide, iron 2, or ferrous oxide. If you have this one, iron is 3 plus, oxygen is 2 minus. Therefore, it's after iron, you write down parentheses 3 to indicate the charge of the ion. Let's do some problems with variable charges, ions with cations with variable charges. This is not a variable charge. This is 2s, one name. That's a B group. That's the transition metal. 3a. This doesn't make cations, but anyway, that's A group. That's a 4a. So this one is a transition metal. It's in the B group with B letters. Therefore, variable charges is ion B. When naming transition metal ion that can have more than one common ionic charge, what is the blank? That's the correct answer. That's what we've been talking about. Which of the following cation has fixed charges? Iron has, the reason we put 3, iron could be 3 plus or 2 plus. Chromium could be 3 plus or 2 plus. This is B groups. If you transition metals, that's a 2A. That always make 2 plus. Mercury is also a transition metal. It's in the B group. All the transition metal groups, all groups have B letter. Therefore, they need to be shown the parentheses after the cation name to indicate which charge is on the cation. Answer is C. This has 6 charge because it belongs to A group. What is the common name? This is cuprous. If you have 2 plus cupric, cuprous is the common. D is the correct answer. What is the common name for Cu2 plus? Can you tell me the answer?
Copper?
Cupric. The 1 plus has cuprous, 2 plus has cupric. Do you see that? Which one is the ferric ion? Iron could have 3 plus, 2 plus.
Mm-hmm.
C is the correct answer.
Okay.
Which one of the following is the ferrous ion?
2 plus.
That's correct. B. Which of the elements do we sometimes use system in naming?
Transition.
Yeah, B group. Noble gases are halogen, alkali metals are main groups. They have normally fixed charges. In the S-X system, which species ic ending? Do you see that? We are talking about positive charge on the cation. Ic means more positive. Us, OUS, is the less positive cation. Now we go over charges of cations, monoatomic, polyatomic, both cations and anions. Let's look at some more detail about sodium chloride. It's an ionic compound. We go know all this because the valence shell is not octet on sodium or chloride, chlorine. It gains, loses electrons. Electrons are transferred to the chloride. The charge attraction is the formation of ionic compound, which is sodium ions attracted to chloride ion. Now, if you look at the ionic view of this, is atomic view is for neutral atoms. Ionic compounds have ionic view. The chloride ions are bigger because they gain electrons. These bigger ions are chloride. These smaller ions are sodium. Normally, ionic compound is a collection of ions packed in a crystalline lattice. These are crystal structures of ionic compounds. That's how you show in a picture. So there are certain arrangements certain ions make. Examine the following image represent the structure of the compound. What is most likely type of bonding in this compound? If you have a collection of regularly arranged pattern like that, it's mainly ionic compound. The correct answer to that, when you see packing of regularly ordered packing like this, that's ionic compound. Covalent compounds have structures like water. They don't have ions like this. Examine the following image. If you look at this image, that's the no covalent compound. This is a covalent compound. This is this image represent ionic compound. Therefore, answer is A. Normally in ionic compound, total of positive charges are equal to total number of negative charges. For example, lithium, we already looked at. The charge is 0. They cancel each out in ionic compound. Barium iodide, this formula of the ionic compound, sum of the cationic charge, anionic charge, is there are 2 of them. Therefore, it's 0. Normally in ionic compound formula, the sum of the charges on cations are 0. This is plus 6. This is negative 6. Sulfur is 2 minus. Therefore, 3 of them minus 6. Sodium and bicarbonate, that's positive, negative, that's the formula. That positive, negative are balanced. Potassium phosphate. Phosphate has 3 minus. Therefore, this has to have 3 potassium. A charge balance is 0. Do you realize that we are summarizing different aspects of how we look at ionic compounds? Let's do a few problems. Formula of ionic compounds is polyatomic ion. What is the correct systematic name of ion FeCO3?
Iron carbonate.
Systematic
D.
is us. This is, how do I know it's 2 plus? Carbonate is always 2 minus. Do you see that? Carbonate is 2 minus. Therefore, common systematic name is 2 plus. Do you guys agree with me? Common is ferrous. Systematic is D. FeSO4, dietary supplement. Following, this has to be 2 plus. How do I get 2 plus? Sulfate ion is negative 2. Therefore, iron is, it should be iron they didn't give the common system. Therefore, B is the correct answer. What is the correct way of writing formula of a compound formed by calcium ion and sulfate ion? Calcium is 2 plus. Sulfate ion is 2 minus. Therefore, charge is balanced. Therefore, this is the correct answer. You don't have to cross multiply to get the charge balance. D is the correct answer. 2 plus 2 negative are balanced. Therefore, you write down, drop the charges. You write down calcium sulfate. What formula of the formed by ammonium ion and carbonate ion? Ammonium is, carbonate ion is 2 minus. Now, if you look at that, that's plus 1, 2 minus. Therefore, there should be twice ammonium per 1 carbonate. So that's this one. This one has 3 times. This one has 2 times carbonate. That's not true. That's 1 to 1. Answer is C. Now let's do a complete review of this. What is the sodium ion here? Name is sodium and nitrate. Calcium and carbonate. Sodium dihydrogen phosphate. Ammonium hydroxide. Iron 2 carbonate. Iron 3 carbonate. Copper 2 sulfate. Barium hydride. That's the sodium ion. Name is the sodium ion is just sodium ion, calcium ion. Nitrate is this. How do you get the total name of the compound? You put them together. Sodium nitrate, calcium carbonate. That's the ferrous common name for variable charges. Cations is variable charges. That's the systematic name for cations with variable charges. Notice you don't write down prefixes for anions, sodium nitrate. This is Fe2CO3. Just you don't write di ion or something. So we finished the naming ionic compounds. We're going to look at some of the common names of acids. Hydrobromic acid is this. HCl is called what? Hydrochloric acid. Hydroiodic acid, HI. Hydrocyanic acid is HCl. Nitrous acid is with 2 oxygen. Nitric acid is 3 oxygen. Phosphoric acid, sulfurous acid, sulfuric acid, hypochlorous acid, chlorous acid, chloric acid. These have one oxygen atom, two, three. The anion names, this is when you lose a hydrogen, bromide ion is formed. Cyanide ion formed from hydrocyanic acid. Nitrite ion is formed nitrous acid. Nitrate is formed from losing hydrogen from nitric acid. 3 hydrogen lost from here make phosphate ion. So this is sulfide if you lose all 4 sulfide, all 2 hydrogen sulfate. Hypochlorite, HClO is called hypochlorite. Chlorous acid is called chlorite, chlorite ion. Perchloric acid, perchloric ion. We're going to look into that. What is the name of the H2SO4? This is not a, this is hydrosulfuric acid. This is, that's the correct answer. Sulfurous acid is H2SO3. So answer is C. When the name of an ion that is a part in that end in I, name of the acid, include us. If the acid has us, the cation coming from the anion coming from the acid, removing hydrogen, is I. What is the formula for hydrosulfuric acid? This is sulfuric acid. This is the hydrosulfuric acid. These are kind of a non-existent acid. D is the correct answer. What is the correct way to write the formula of a compound hydrogen ion removed from ions? Hydrogen and sulfate. That is the correct answer. Sulfate can gain 2 hydrogens, ions. That's the correct answer is B. Now we're going to go into covalent bonds. This is the second part of bonding. We completed ionic bonding. Went over naming ionic compounds, all kind of ionic compounds, monoatomic, polyatomic, cations with variable charges. Now let's look at how we approach covalent bonding. Then we're going to talk about naming covalent bond. Covalent bond is formed by sharing electron pairs. The pair of electrons, two electrons, by both atoms, one by each, from the valence shell of each atom, shares to form a covalent bond. For example, hydrogen has Lewis structure. There are two electrons on each. So this bond is covalent bond. They share, they don't transfer. Normally non-metals do this. Between metals and non-metals, ionic is most common. In covalent compounds, covalent bonds are formed to satisfy the octet rule. For example, water, two hydrogen and one oxygen. We go know this. Two covalent bonds are formed, two covalent bonds, and two lone pairs of electrons are found on the valence shell of the all atoms. A Lewis symbol is also used for molecule where it's bonded by covalent bonds. Ammonia also shows three covalent bonds here and one lone pair of electrons. Methane, four covalent bonds, and there's no lone pairs. Bonding electron pair is also called bonding electron pair, is the electron pair shared between two atoms. Lone pair is an electron pair shared by only one atom, like oxygen here. Nitrogen has one lone pair. Hydrogen has two lone pairs. Methane, which is natural gas, don't have any lone pairs. So we use Lewis structures to show the electron distribution in the valence shell of a molecule formed by covalent bond. So drawing Lewis structures for molecules is important step in describing covalent bond. How do you write a Lewis structure for a molecule? You first start with getting the total number of valence electrons in the molecule. Then distribute to get the octet. And first you get the total number. For example, water. Two lone pairs coming from each hydrogen, six valence electrons are on the S 6A. Total is 8 or 4 electron pairs. So you have to determine the connectivity of that. Which one is bonded to which? Oxygen is the central atom in the water molecule because it makes more bonds. Central atom is bigger and make more bonds. So you connect the central atom to terminal atom. Terminal atoms are hydrogen. So two single bonds are formed. These are called bonding electron pairs. There are 4 pairs. 2 is already used for bonding. Therefore, you put the 2 non-bonding. You can write the Lewis structure for oxygen. Eight electron pairs. Octet is single bond, 1 electron pair shared between atoms. There was a possibility when you share between 2 atoms more than 1 electron pair, 2 electron pairs is a double bond. Single bond is the 1 electron pair. Triple bond is 3 electron pairs. For the Lewis dot symbol, that's the element with 5 electron pairs. It's just like nitrogen, phosphorus group. Appropriate number is 5 valence electrons. Therefore, this symbol indicates 5 valence electron pairs. C is the correct answer. How many covalent bonds are generally formed by oxygen atom? You go to the Lewis structure. Oxygen is two single atom, single electrons, therefore 2 is the correct answer. Lewis dot symbol shows the number of bonds. How many total valence electrons does the ammonium molecule contain? 5 on the nitrogen because it's 5A. 1 on the, there are 4 of them, 4 hydrogens plus hydrogen. There's a charge on here. Charge is -1. Why charge is -1? Positive charge is losing an electron. Therefore, total number of electrons are 8. We sometimes show the 8 divided by 2 is 4. 4 electron pairs or 8 electrons. Total of valence A is the correct answer. How many? This is the Lewis structures. You have to count the number of valence electrons on the whole atom, whole molecule. That's 6. That's 7. Bromine is, oxygen is 6A, bromine is 7A. When you have a charge, you had to add 1 more. So 6 plus 7 is 13. It's 14 electrons or 7 electron pairs. 14 is the correct answer. What is the correct Lewis structure of ammonia? Ammonia has 5 plus 3. How do I get 5 plus 3? valence electron. This is 5A. This is 1A. Three of them is 3. 1A has 1. Therefore, 8 valence electrons. If you look at the Lewis structure should have 8 electrons. If you look at this, each line is 2 electrons. Each dot is 1 electron. If you look at here, there are 3 of them. That's 6. There are 4 dots. Total of 10. You cannot have more than 8 or 4 electron pairs. Therefore, this is not the correct answer. This one has only 6 electrons. There are 3 lines. 3 lines means 6. If you look at this one, each line, 3 lines, 6 plus 2 is 8. So this should be the correct answer. The connectivity is not correct here. And the 8, there's only 6 electrons. Therefore, that's not the correct answer. Therefore, correct answer is C. How do you write Lewis structure of carbon dioxide? Carbon dioxide is, carbon is connected is this. You count the total number of electrons is 4A. 4, this is 4. Oxygen is 6A. 6A times 2 is 12. 12 plus 4 is 16. Divided by 2 is 8. When you connect carbonate ion, you already use 2 electrons. Now you have to put the octet. That has 8 electron pairs. 1, 3, 4, 5, 6, 7, 8. So this is the correct Lewis structure for which one is the, this one has 8 valence electron pairs or 16 electrons. Therefore, A is the, this is wrong. This is not carbon dioxide. This is correct connectivity, carbon dioxide, but the wrong electron pairs. This has less electrons. Therefore, this is not correct. This is not the connectivity of carbon dioxide. It has to be A is the correct answer. What do you think what the structure of water is? That's 2 plus 6, 8, or 4 electron pairs. This is the correct structure. This has 3 electron pairs. This has 4 electron pairs, or 8. This has 1, 2, 4 plus 6 plus. But that connectivity is wrong. This one have less electron pairs than 8. Therefore, correct answer is this one. What is the correct Lewis structure for HCl? HCl has 1A, 1 electron, 7A, 7 electrons, total of 8 electrons. This is the correct answer. Rest of it is, there's no double bond between two chlorine, and that's not correct. This is only 2 electrons. There, hydrogen have a lot more electrons. Hydrogen cannot have more than 2 electrons. Therefore, answer is D. This water has 8 electron pairs in the valence shells of all the hydrogen and oxygen atoms. So structure is central atom is oxygen, then you connect the terminal atoms and fill octet duet to hydrogen and hydrogen duet, oxygen octet, you get the structure. Ammonia also has 8 valence electrons coming from nitrogen and hydrogen. Then you have 8 electron pairs, 4 electron pairs, total of 8 electrons divided by 2 pairs. Since we write bonds with the arrow is a pair, so normally we go ahead and count the pairs. Methane has 8 electrons from 4 from carbon, 1 each from hydrogen, that's 8 total. 4 electron pairs. Now we have 4 bonding electron pairs on the methane molecule. HCl, we already done that, 8 electron pairs. The octet is around the chlorine, hydrogen has a duet. Now total electron pairs are 4, 8 divided by 2. That's how you get the Lewis structure. Now when you have methane, this molecule is called ethylene. The connectivity is carbon is bonded to each other. Connectivity is carbon bonded to each other. The total number of electrons are 12. 6 times 2 is, carbon has 4. 4 times 2 is 8. 8 plus 4 is 12. You get the 12. There are, after you make the connectivity, connect carbon and terminal atoms, you have 1 more electron pair. This is 12, 6 electron pair. This already used 5, 2 each. So you put a double bond to get the carbon octet. So that's how you get, this is acetylene. It has a triple bond. Total number of electrons is 2, 1 from each hydrogen, 4 from each carbon, total of 10 electrons. 10 electron is 5 pairs. Therefore, 1 here, 1 here, 3 here. The total number of valence electrons are counted. Formaldehyde also has the carbon as the central atom. Total of, if you count the carbon, 820, total number of 4 from carbon, 2 from hydrogen, 2 hydrogen atoms, 1 from oxygen atom, total becomes 12. 4 plus 2 plus 6 is 12. There are double bond here. Octet is for the oxygen atom, octet 8 electron, 4 pairs around the carbon. Therefore, it's correct Lewis structure. Carbonic acid also has that Lewis structure. This is kind of complicated. We are not going into that kind of thing, but once you get the connectivity, carbon is in the middle, 2 oxygen are attached to carbon, the oxygen attached to carbon, and hydrogens are attached to one each on the OH atom. All the carbons, oxygens have octet, hydrogen has 12. Therefore, total number of 24 electrons or 12 pairs. So that's the correct Lewis structure for carbonic acid. Now let's answer some questions about Lewis structure. Which of the following molecular compound is same as covalent compound would have Lewis structure that contains 10 electrons. Now you have to count the electrons. How many electrons HCN has? How do you get that? HCN. Carbon, hydrogen has 1, carbon has 4, nitrogen has 5. So 10 electrons. So this should be the correct answer. Water has 8. Ammonia has 8. Carbon dioxide, we already calculated. It has 16. Carbon dioxide has 4 plus 12. Therefore, HCN is the one has 10 valence electrons. The dots, electron dots are going to be the valence electron in the Lewis structure. Now you have to know this on the side I wrote down. You look at the group where the hydrogen is, 1A, has 1 electron. Hydrogen is in the 1A. Carbon is in 4A. It has 4 valence electrons. That's how I get this number. Oxygen has 6 valence electrons, 6A. Remember, we've gone over this. Answer is A. NO2 Lewis structure. NO2 plus Lewis structure. Now you have to answer question about this. First you have to draw the Lewis structure. Nitrogen is central atom. Why? Nitrogen makes 5 bonds. Nitrogen makes 3 bonds. Covalent bonds. Oxygen makes 2 bonds. Therefore, nitrogen is in the middle. You connect with the one line electron pair. So total number is 5 plus 12 from oxygen. When you have a plus charge, that means 1 electron is lost. When a group of atoms lose 1 electron, it can have positive charge. The total number of electrons is going to be 11 plus 5, 60. There are going to be 8 electron pairs. So when you look at this nitrogen, how do you get the Lewis structure? You put octet to carbon, oxygen, terminal atom, connect with center. Now you already have 8. You see, you have 8, 4 here, 4 here. Now you cannot have more than 8 on the structure. We draw a double bond. So therefore 8 valence electrons, 1 single bond, 1 double bond, and 5 non-bonding electrons. 2 double bonds, no. 8 non-bonding electron pairs. This only 5 non-bonding electrons. 1 bond, double bond, single bond, 12 non-bonding electrons. 12 non-bonding. 1, 2, 3, 4, 5. 10 8 non-bonding. I am counting here. This is only, that's 2 double bonds. That's the octet. Here, octet. I didn't draw the 2 double bonds. 2 double bonds. 8 non-bonding electrons. The answer is A. Did you see how I got it? It was kind of a tricky. How many non-bonding electron pairs in the Lewis structure? Carbon dioxide. I got the answer already. If you look at this structure, how many non-bonding electron pairs? There are 4 of them. 4 is 1, 2, 3, 4. Answer is B. I already drew the Lewis structure for carbon dioxide in the previous problem. Formaldehyde, Lewis structure. How many electrons must be shown in the Lewis structure? Formaldehyde. The number of dots that should be shown in the Lewis structure should be sum of the valence electrons. Therefore, this is 4, this is 2, 1 times 2, 12. 12. C is the correct answer. Ammonium ion. How many electrons must be shown in the Lewis dot structure? Ammonium ion has 8 electrons. How do I get 8 electrons? 5 plus 4. 1 times 4 is 4. 1 times 4 is 4. Minus 1. Why minus 1? When you have a charge, you add subtract. If it is a negative ion, you add 1 electron. So this is 8. Therefore, 4 pairs. So how many electrons must be shown in the C is the correct answer. Hydrogen cyanide. How many must be shown in it? We already did that. 10 electrons. Remember we did that for one of the problems. Should be C. Covalent compounds with multiple bonds. We already talked about carbon dioxide, ethylene, acetylene. How many bonds does carbon typically form? Carbon typically forms 4 bonds. How do you get that one from Lewis structure? Carbon has this grid structure. When you're making bonds, when you have 4 electrons are shared, they become single electron. Therefore, carbon forms 4 bonds. Answer is B. When you're making Lewis dot structure has a lone pair, but it gets excited to 4 4 lone pairs of electrons, which could be shared. So therefore, answer is B. How many carbons carbon make? 4 bonds. How many bonds carbon make? 4 bonds. Nitrogen makes 3 bonds. Oxygen makes 2 bonds. Chlorine, halogen group make 1 bond. We look at ethylene. Ethylene has a structure of this. 1 double bond, 1 double bond. B is the correct answer. Acetylene has this structure, triple bond. Therefore, acetylene should have a triple bond. Correct answer is C. Which of the represent the best Lewis structure for acetylene? C2H2. Remember, Lewis structure is, we go know this, you count the C2H2, 8 from there, 2 from there, it's a 10 electron divided by 2, 5 pairs. So you connect the carbon first, then hydrogen has to add. These are now, you have to put 3 bonding electrons to get the octet. Now this has 8 electron pairs, 8 electron pairs. So best, which of the following represent the best Lewis structure for acetylene? A. Are you guys
Okay,
here?
sir. Yes, sir.
Okay. I will see you on next Monday.
Okay. Thank you, sir. Bye.
For coming. Sign up the chat box. Okay.
Mm-hmm. Mm-hmm. Thank you.